We did
They can hear me.
triple-checked. I
Okay, there.
triple-checked. Okay, you can hear Seth and you can hear me. Excellent. All right, good. So, welcome everyone. Thank you very much for showing up for our user group meeting. We've been doing all these virtual for this year. We're starting a bit earlier this year. We typically are this month. We typically don't do them until the last of the month. It's usually the last Tuesday of every month. So that would be the 29th. But because of Christmas and Phil had some availability, Phil Seamark, who's our speaker tonight, we decided to pull it a little early and do it here on the 15th. So, uh, Seth, you want to just say hello and we'll kick things off.
Yeah, as soon as we triage an echo, that may or may not be happening, but I think we're okay because Dan says we're okay. Yeah, excited to be here today. Excited to have November and December meetings for that matter, because typically we bail out in the in-person thing. So this is the first year that we're continuing on, and super thrilled to be able to serve up one of the best in a particular requested area that our user group, a bunch of people have a lot of interest in modeling and aggregation tables. So the talk tonight is pretty cool from the standpoint. I think that the idea came up in one of our after hours chats, and in 5 minutes, Mike had Phil committed for this evening's
We
talk.
move quickly here at
So
Power BI Tips and
yeah.
Power BI User Group. We don't screw around. We just we get to the game.
So I don't know if you introduced yourself, Mike. For those that may not be aware, my name is Seth Bauer. I'm actually the director of business intelligence at a company called Syndigo, but in my otherwise non-free time, I co-lead this Milwaukee Brew City PUG, which you are now participating in. Co-owner of PowerBI.Tips, where I do a bunch of blogging, building some tools, and then we do speaking and videos. And all that's kind of culminated into a Microsoft MVP in Power BI.
Name's Mike Carlo, owner of Carlo Consulting, and do just a bunch of consulting work around Power BI. Also run the site PowerBI.Tips with Seth, and have a lot of fun just in Power BI in general. So with that, I'll just do a couple quick announcements. So two things you guys should know about. I'll see if I can transition correctly here to the screen share. All right, so I'd like to introduce you to the newer version or view of Power BI Tips. We've updated the background a little bit. We tried to improve some site speed things over the weekend. I spent some late nights kind of just tweaking the website a little bit, tried to make it a bit wider screen so you get a little bit more landscape out of it. We had an awesome article just recently published by Steve Campbell, the Power BI architecture and data solution is doing really well right now. So would highly recommend you go out and check it out, read that article. It's pretty fun. You'll also notice here in the middle of the screen, we have a new little button here called clothing. So I will click that for you. I'm very pleased to announce, for those of you who follow us or have seen us on Twitter or LinkedIn, you may have already seen this. But now we've got a bunch of Power BI swag things. So I made this Power BI branded shirt. Some things here that you can also check out. We have some interesting clicky, draggy, droppy logos and icon things on shirts. So in case if those are your bag of tea or whatever I guess you say, you can go get some swag stuff. So anyways, have fun with that. Enjoy that. Check it out. It's on the website. You can go link to it if you so enjoy that kind of stuff. Anyways, figured I would point that out, and let's go over to Phil. Just transition over here. All right, let's see if we can get the screens to work correctly.
Well,
There we go.
while he's messing around, I'm super thrilled, super excited to have our good friend Phil here. It's been a long time since we spoke, so happy to have him. I don't want to steal any of your biographical thunder, Phil, but Mike and I met Phil when he was a Power BI MVP, and we became, kind of fast, long distance friends until he got sucked up into the mothership of Microsoft. And probably joined the coolest team on the planet. So with
Yes.
that intro, Phil, take it away.
Cool, thanks for that, Seth. And I was actually planning on being here in your
Yeah,
user group in
we
person
tried.
at some point. So it's a shame to do this virtually. And hopefully sometime next year I can make it over, especially if it's NFL season. Because as Seth and Mike know, I am
Yes,
fond of the Packers, and aren't they going well this year?
Much
they
Are they
better.
gonna?
indeed are.
Is this their
This
year?
could be the year. I hope it is.
I
Right. Always
Fingers
fingers
crossed, right?
crossed.
I'm not sure how many people dial in are from the Green Bay area, but I am watching all the games, really enjoying it, and
so far so good.
But yes, I do plan to come over in person.
person.
Hopefully this time next year when we will can. So as Seth said, I work for Microsoft now. On the Power BI team, and more specifically on the Power BI CAT team. Stands for Customer Advisory Team. So we're a very small team, but we spend a lot of time working with large enterprise customers, having a look to see what's blocking them, helping them understand, Power BI a lot better, and helping make their very big systems run quickly. And we get to work on some very large models, multi-billion, 100 billion row tables and models.
Let that sink in there.
So
you said 100 billion? 100.
Hundreds of billions of rows. Yeah. And we do what we can to try and help that run fast for a large number of users. So we learn a lot. This is the great thing. We learn a lot when we have the opportunity to get hands-on and figure out how to tune these big systems. And so sessions like this is a great opportunity to actually share some of that learning. So the topic today is going to be about aggregations. Now I have to be careful with my accent, because I quite often refer to them as aggs, and I'm not talking about things that chickens lay. I'm talking about aggregation. So I'm not sure if that's how it sounds to you, but if I say, we create some eggs, we're not talking about eggs.
There you go. Just in case.
Just in case, yes. So we're going to be talking all about eggs and different types of eggs and how you can use them to solve different problems, and what egg technique or solution suits different challenges. So that's what I'm going to spend a little bit of time. Mike, have been cleared to interrupt me and drop in a question if it makes sense at the time.
All right. Your presentation is
with
up,
that,
and you should be good to go. And Seth and I will monitor the comments area on YouTube. So if anyone has questions, please ask them. We want you to ask questions about anything you think about ag tables or what's going on here. If you want to explain a little bit more deeper, please jump in, make sure you comment, and that way we can fix it and get it all in the. We'll pause Phil and we'll get the questions in and get your questions answered. So Phil will also be around just for a little bit afterwards. So we're going to do our traditional presentation for the first half of the meeting, and then we'll do happy hour on the latter half, and that's where we will share the Teams link, and then Phil will just hang out and chit chat with us, and we'll just have some fun on a Teams meeting. All right, Phil, take it away, buddy.
Cool. So here's the agenda for today. So first of all, we're going to introduce what are aggs and just describe them in the most simple, most basic way. And then what we're going to do is spend some time looking at some interesting variations on what you can do with aggregation tables or aggs to help speed up your model. But first, I thought I'd just give you a little bit of a geography lesson. So you can tell from my accent, I'm not local to Wisconsin. I'm dialing in from New Zealand. Now, New Zealand is all the way down, and we're doing pretty well with COVID this year. And a lot of people go, "Hey, you guys are doing such a great job. How come that is?" And a big reason, hopefully you can see this okay, is because when I get a ruler and I sort of draw a line between us and the nearest country, this irrelevant small island over here to the west, you can see that we're 1,200 miles of moat. Which is pretty good. And that's to the nearest country. If we were to get rid of this ruler and start having a look, how far away are we from this little country over here? It's 6,000, 7,000 miles to Canada. Let's bring that down here to the US, just over 6,000 miles. So it's a fairly long way. So we're doing pretty well. In terms of New Zealand, the
Yeah. Yep, that's right.
area, but there aren't many people, so the population density is fantastically small, which some people like, some people don't like, but it's great for times like COVID, because I think, when you have very, very densely populated cities with subways, it can help the transmission of these sorts of things as well. So we don't have many cases, and hopefully that stays the same. But please, you're very welcome to come down and visit, and let me know, and I'll show you around. So that's my geography lesson. You know where I'm dialing in from. And by the way, I'm in the middle here somewhere. I'm about this point here. So let's talk about aggregations, or AGs. What actually are aggregations? So quite simply, all aggregations is they're a data modeling technique to help you speed up queries over large tables. Effectively, they're summary tables. So the objective of an aggregate table is to allow calculations to return the same result, but using a table with fewer rows. Now, why should you care? And in very large models, and let's say you have a table with 100 million rows, and you want to do a sum of a column in that table. Now, you could scan every single row in that table, and it's pretty quick. Modern day technology and in-memory tables means that can happen very, very quickly. But if you can create a summarized version of that 100 million row table, and that's only, say, 1,000,000 rows, and summarized by month, and your calculation calculate some values that go into your row, so that your query that says, hey, how much did I sell by month, for a given product, whatever, you can just simply scan fewer rows. That's all that it's about. So I like to think about it in some ways like gears in a car. If you, and the lowest gear is your detail table with no eggs. You're just only going to get over so much distance for power. But if you can introduce multiple layers of eggs, that's like introducing multiple gears in your box, and that fifth gear, you can cover a lot of ground with not too many revolutions, which is pretty efficient. And why are these important? Now, I think back to fairly early in my BI journey. I'd worked for a couple of companies, and I'd learnt how to build multi-dimensional cubes. This is going back before tabular, sort of. Actually, let me think. 2014. So tabular was sort of fairly new, but I'd worked at some organizations that had multi-dimensional cubes. And what you do there is you bring in your detailed data, and almost automatically what it does is, because it was storing the data on disk, which is relatively slow, is they would automatically help you build aggregation tables for you. And I walked into the door to this new company, and they had a model that people were querying, and the average query time was 5 minutes. So when they would open the browser and try and load the report, the average query time was 5 minutes. And this is on the first morning of being in this organization, and I had a look, and the person that had built the model, they had turned on aggregations, but they hadn't processed them. I don't think they realized what they were actually doing in the model. So I noticed the switch. I turned it on, and about 30 minutes later, after they hydrated, they populated, without touching anything else on the system, without changing the report, without doing anything. The queries were all finishing in 1 or 2 seconds, and they thought that I was some sort of magician. And I'd done some really,
awesome.
really amazing things, but all I had done was just turn on these aggregation tables. So what would happen is the engine automatically would go, okay, I know you're trying to plot a line chart for sales by month, what I'm going to do is check to see, can I resolve this from one of the many aggregation tables that are around? And if I can, I'm going to use it. And obviously done. But if they're not available, they're not turned on, they're not populated, whatever, it was then going down to the raw detailed table, which was just slow. So well worth doing. And in fact, what we have now in Power BI or Analysis Services Tabular is we've got a feature called Aggregation Awareness, which automatically allows you to map an aggregation table to a detailed table. So what happens is, imagine you have a very big fact table with one row per transaction, and then you manually create a summarized version of that table grouped by day or by month or whatever. So you manually create the summary table, and you have to do that. We don't create that for you as yet. But then you can turn on a feature in Power BI called Aggregation Awareness, where you define as a one-off task a set of mapping rules to say this little summary table over here actually can be used as an alternative to the big long fact table, but only for these columns. And if the query happens to match on those columns, then use me instead, and that kicks in automatically. And you can have as many aggregation tables as you like. You probably don't want to have in the order of 200 because you would need to refresh those 200 tables, and you need to make sure that these ag tables keep in sync. But if you have a handful, 2 or 3 at different grains, and covering different mechanisms of slice and dicing, then your performance of your reports is going to go through the roof. And I mean, I like to think that if you've got a really critical report that your company uses, then ideally, when you first arrive at that page, all of the visuals, when they're first presented to the end user, should be hitting an aggregation table, an ag table, not going to a detailed table. So if it's escaping through to your detailed table, then it's probably a good candidate for an aggregation to have a look at. But it takes time. It's not it's a little bit of a science. It's not something that you can just set up quickly in half an hour like my earlier example. It's something that we're making better. We're introducing a whole lot of new functionality around this coming up to automate and help you identify based on query patterns, what aggregation tables might be useful to your particular model, because it always depends on what your users are doing and what kind of visuals you've got. So we are definitely making that better and easier. And it's not just the realm of large, big, massive tables as well, models. If you've got models that are medium size, aggregations will still make a big difference to those. And it's not something just for the big enterprise models by any stretch.
So someone asks on the chat here, they're just curious. I think it was I can't remember the name. Oded, if I got it right. He was asking, are you going to be able to go through starting an ag or building an ag from scratch today? Because he was really curious. He's really looking into it. He's looking for resources right now. Is part of the demo today going through and building an ag kind of from scratch?
Sort of. My very first example showing aggregate awareness, I will have 2 tables, a detailed table and an aggregate table of that. And I'll show you before and after the performance. Now, my detailed table is 50 billion rows. Wow. So that's pretty decent, and we'll be able to have a look at the before and after performance on that.
Excellent, perfect.
So hopefully that covers it. Otherwise, at the end, maybe we can set some time at the end of the live stream and see. But you can create your ag tables anywhere. You can create them in the source system, like as a SQL statement, or a physical table in your data source, and then import. Or you can build them on the fly in Power Query, or you can build them in DAX as well. And there's pros and cons for each of those approaches. And then once you've got your aggregate table in your model, then you can set up ag awareness if you like. It's not essential, because you can use DAX to do the same thing. I wouldn't recommend it because it requires a lot of DAX. And hey, I like DAX, but I like small DAX rather than big, long, complex DAX, but it is possible. And in fact, I think one of the techniques I'm going to show you today does have about 50 lines of DAX to sew it all together. Now, everything I'm talking about today is on my blog site, dex.tips.
And I'll go get that because that's a really good resource. I'm so flustered that I didn't get to dex.tips before Phil did, but he did, and he stole it out from underneath my nose. So
yeah, I needed to come up with a brand for my blog site, and it was dex dot something. It's like, hey, tips is there. It's
I
cool.
missed out on that one. I
I need
totally
to
missed
get
the ball on that one.
and a dex.tips
There we
hat.
go.
So
I like it. See, now we're rocking. We'll have to send you some new swag as it comes out.
okay, so let's have a look at classic aggs. Let's get into this. So we're going to do the very basic vanilla, plain, boring, simple agg. And how do these help your model? So the problem is, you've got big data, you've got lots of users, slow reports, you got reports with tons of visuals. So the answer is, look at using summary tables. So and a really simplistic version of this is here. So if I have a H row table where we have, whoops, my mouse is touchy. Every time ignore that. So the table has 8 rows. We have a date column, a product column, and a quantity column. Now, if I wanted to sum quantity by date, I could scan 8 rows and just extrapolate that out to 8 billion rows, say. And if I was to sum this number up, it would take me a little while to do that. Now, if I create a small summary version of this table, like I drop product altogether, and I say I want to group by date, and we've got 2 dates, so therefore we have 2 rows, and I sum up quantity, then I can sum up the value here. And also what I can also do is, as part of the grouping, keep track of how many rows are in there. So there are some calculations I can do here. There are some that I can't do. So quite simply, if I wanted to understand my overall sales, I can just say 46 plus 62 is 108. And it's going to be faster than scanning down here. I can do some things like averages. I can't do a max or a min calculation with the summary table as it is. But if I introduced additional columns into my 2-row summary table, and I have a column that keeps track of what is the max for that day and what is the max for the next day and min, etc., then I can start doing those types of calculations. But I pre-calculate this, and ideally when it comes to my end user loading the report and the visuals are arriving at the numbers they need using this much smaller table than the small table. What I can't do on this little table is any slicing and dicing by product. So I can't use this table to say, what is my total sum of quantity for product A? We've just lost that grain. I would then either need to drop back down to my detail table, or perhaps I have another aggregate table over here, which is grouped by A, but maybe not grouped by date, for example, and it sums these sorts of things up, if that's a common calculation that my visuals like to do. So that's in a nutshell, that is the classic agg. And if I want to demo that using a very large version of the database, let me switch over to a Power BI report. So what I have here in front of you is I have a table down here, which is 50 billion rows of data. It's not a complex table, and this is actually real telemetry. It's some internal Microsoft stuff that's been anonymized over a couple of years. So we've got 1 row per, each row in here is an activity that took place, like a user hitting a particular product. And in here, we know the date that the action took place, the device they used, where they came from, operating system version. There's a couple of ways that we can slice and dice this table. But importantly, I want to know what was the quantity for this year. And I can create a measure over this. I mean, I can slice and dice by these, by any one of these dimensions, by date, device, geography, etc. So if I go back to my report, and let me just bounce around here. Hopefully that's catching up.
Everyone's freaking out by it. Whoa, 50 billion. So I just,
50 billion.
they're flipping out because it's such a big table, and which I would have to say, I mean, this is probably like, every user hitting PowerBI.com or something like that. I mean, 50 billion sounds appropriate for, 5 years of amazing Power BI data.
Yeah, so I have a measure, an explicit measure that just simply performs a sum over a column in that table. That's all it does, nothing complicated. And I've turned on my performance analyzer, and if I drag that measure onto the canvas, we're going to get the little spinny bar, because it's generated a T-SQL to fire off to the source. This table is out in Synapse DW. And I think if I wait 2 or 3 minutes, this will turn up because it's just going to sum everything in the model. And if I start slicing dicing by any one of these dimensions, it's going to get even worse. So I'll spare us that. I'm not sure if we can stop it. So let's go back to the model. And what I can show you is a version of this that has the aggregate table in it. So I have a fact table, but I also have a aggregate table. Where's my aggregate table gone? Oh, this is the ag table, sorry. This is the ag table. Let's show the full table. So this is the column that we're querying. So we're summing up this quantity this year. Now, my fact table is in DirectQuery mode, has 50 billion rows. My imported aggregation table is obviously fast because it's in memory. Let's go and have a look to see how many rows are in this aggregate table. We have got 12 million, so quite a significant reduction in number, and it's aggregated by day, by device, by geography. It's aggregated by all of these dimensions. It's just not split out to many millions of transactions per day. But to get this working with aggregate awareness, I need to go and enable that using a simple dialog. So on my imported aggregate table, and this is the demo that I in mind that I was going to show, I click on here and I say, let's manage aggregations. And that's going to bring up a dialog where I can define the mapping. So I mentioned we can say that a column in my aggregate table can be an alternate of the same column over in a detailed table. So I'm going to scroll on down and say that the quantity this year in my aggregate table is going to match my fact table for the same column. And I'll do the previous year as well, so we can do some time intelligence.
So Phil, let me pause you there just for a second because I think this question is very timely. So you're defining on a row by row kind of what the aggregations of this new table are. Oded is asking,
column
by column. Oded is asking specifically, how did you make the ag table? Is the ag table made with like a SQL statement that is then imported directly into the model? So you're basically running like you have one table DirectQuery, that's the main fact table, and then the ag table is just like a SQL statement or a SQL view, and then you're just doing an import mode on that table. Is that correct?
Yeah, it's
Okay.
exactly that. Yeah. So in this particular case, what I did was I created using SQL a physical table in my DW. So I have 2 physical tables in my DW. I have a 50 billion row fact table and a 12 million row aggregation table. And then I import the 12 million row one into my model. So my model's quite small. My model is only 36 megs. But I can slice and dice over 2 years of a huge amount of telemetry data, and it's just 36 megs of imported memory, and it's probably compressed even more. If we had a look at the DMVs, but we're not going to. So I've gone and defined
Thank
this.
you. That answered the question. I think we got there because I think the question was really around like we didn't know how to make the aggregation table. So you don't have to make it in Power Query. You can make it in other source systems and then bring it forward. Perfect.
Yeah, it really doesn't matter. Use the power and the capability of the best.
The Synapse.
What the tools that you have available. Yeah.
Okay.
So I've defined this mapping. That's all I've done. So now I can close out of this dialog and go back to my canvas. This seems to just lag a little bit. Here we go. And this has been super quick. So the event measure only took less than a second. But let's slice and dice this a little bit. Let's put on calendar year. And we can slice and dice now by anything on here. And that's pretty quick. Now let's put month in, or even day. Let's put date key in, or day, axis, and drill down. Turn that into a line chart so we don't have to scroll. And I hope you'll agree that for 50 billion rows of data, this is relatively snappy.
Plus, you're also, is this the same computer you're streaming off of as well? Because it's probably also having a good heyday of the video
I'm
too.
just pumping up my CPU. Yeah, I'm just actually beefing up my CPU a little bit there too. And I'll take our date key and put in day into axis. Maybe take that out. Here we go. It's starting to respond a little bit nicer now. And if I can put device in here into my legend, there we go. You know, so it's pretty snappy now. And that's because it's everything I'm doing now on my visual. It can grab from ideally from my 12 million row table. And I haven't had to write any code into my measure. My measure is still simply this. It still thinks that I'm performing a sum over a column in my very large detail table sitting out in my DW. And if I was to let this escape, then it would take a little while because I don't have my DW scaled up very high. It's set at the cheapest, most bare minimum setting. But this will work pretty nicely. So that's the classic ag, and that's how you can configure it. And you might want to have 2 or 3, and you mix and match how you slice, connect them. There are articles that describe how you walk through setting them up from scratch. But I just wanted to demonstrate how the the calculation will behave before and after having the aggregation there.
So
that's the basic ag.
Hey Phil, I think hold on a second. Let me transition here real quick here. I got to get.
Did you mute?
I'm trying not to mute everyone here, so there's a bit of an echo here. So hang on, Phil. Let me get Seth in here real quick he's got a question. All right.
Sure.
Go ahead, Seth. Answer and ask now.
I will ask.
There we go. We got it.
So, Phil, when are ag tables most useful? Is it only in direct query scenarios, or is this a case where anytime I'm aggregating large amounts of data and I still have a granular fact table, that it's useful because of performance improvements on the model and how
it's okay. There's 2 things. First of all, let's say you import all of your data all of the time, and you want your reports to run faster. Mm-hmm. Then you can create summary tables inside that same model as obviously import. And you've got import over import. Now, you can't use aggregation awareness, that feature I just demonstrated, when all of your tables are in import mode. You would have to do it manually in DAX. So you would have DAX. Within your DAX, you would do a bunch of if tests to go, hey, if certain slices were in play or certain dimensions are being filtered, then I can use my ag table. Otherwise, go to my detail table. And what will happen is your data model will grow. So if you started with a 50 gig model and you apply that technique, you might end up with a 51 gig model, and that just gives you out and out performance. That's all it's about. However, Power BI has a fantastic feature called composite model, where what that allows you to do is take a 50 gig model, like we just described, where everything has been imported, and you can take your very large fact tables and drop them out to a data source and put them out to DirectQuery. That might shrink your model down to about 5 gig. You still have to store that data out in the data warehouse. But what you try and do is you create a set of ag tables in import mode that cover, ideally 90% of all queries that get generated. So when the users first load the report, all the queries that get generated for each of those visuals are being resolved from one of the imported small ag tables. But it's only when they start drilling down, they like right click and they drill down, and they stop hitting an ag, then that particular query, which is very focused, if you can imagine the SQL where clause, it's like, where day is this, where category is this, where geography is this, that escapes. that gets fired out to your DirectQuery data source. Ideally, it can turn that around very, very quickly, like in a half a second or a second or something, and it returns the results, and the results can be displayed. But what you're shooting for is 95% of your queries are hitting ag tables. And so you end up with a data model, which is, say, only 5 gig. Now, if you're buying a premium capacity Power BI Premium, and you've got 50 gigs, well then, hey, you can fit a whole bunch of extra models in there. It's really good use of capacity. And because you can store your data out in a cheaper data warehouse that, doesn't have, it's obviously not as quick as imported data, but it's not having to receive as many queries, and, it can do, most of the concurrency load has been handled by the imported ags. So it can, it's not getting saturated by lots and lots and lots of queries. And it's a tuning mechanism, but it does mean that you're not getting straight out and out performance in the first example where everything's imported, but you're getting a mixture of better use of your capacity, and you're still probably getting faster performance as well, because anything that hits ag tables is definitely, imported ags is going to be pretty fast.
Phenomenal explanation. So thank you for that. I don't want to derail where you're at right now, but at some point I'd love talking through some use cases you've seen where migrations or ag tables are really effective.
Yeah. Typically, the larger the data size, the more they come into play. The more they are going to be useful. But I think even in small, medium size, if you really want your model to respond fast, Formula One tuning type thing, then ags are your go-to. That gives you those gears and that speed and
yeah. I guess one of the thoughts I was thinking is do you see the use of aggregation tables for looking at certain time periods, right? Like the most recent 6 months or a year, and then you have a direct query for things further out than that.
I have a slide for that. So
gotcha.
There it is.
Okay. I'll hold this. Sorry.
So let's crack into it. So I've got a whole bunch of techniques. So it's part of working for various customers. These are some of the solutions that we've come up with, that we've applied successfully, that have ended up improving the outcomes for the customer. So the first one we're going to talk about is horizontal ags.
For those of you who are listening, this is the part where you really need to listen closely, because what Phil's going to talk about now, these are patterns that you maybe, in my mind, I thought ag tables were a thing, and I kind of had my head around what I thought they were doing. And the basic use case is what I had in my mind. Phil's going to come up with you. There's the cases that he's going to present now. These are the really cool use cases where some of them are pretty basic, but the idea here is my mind was blown when Phil was started telling me some of these ideas and how these different ag tables can be used. So I just want to make a quick note here to the people watching. Play close attention, because this is really cool stuff, and I've never heard this stuff before. This is all brand new information to me. So I think you guys will really enjoy this next part. All right, sorry, Phil. I didn't mean to interrupt you. Keep going, bud.
No, that's all good. So there was a particular customer where what they like to do was they only ever ran queries and built reports based on whole date ranges. So excuse the dates here. They're a bit old. This is when I put the slides together, 2018, 2019, but they could be any time. But just imagine that the customer liked to do date ranges. Now, the date ranges would vary. So sometimes the reports would be 123 days. They would all be contiguous days, all joined up. Sometimes they might be 17 days. Sometimes they might be 90 days, 21 days, etc. And the challenge with ags is normally the way you normally generate aggregation tables is often you group by time, because that's the most common dimension across most data models. So you might create an aggregation table like in my previous example, which was grouped by calendar day, or you might create one by calendar week or calendar month. And if your date range happens to match a calendar month or a calendar week exactly, that's great, because it can use that. But the problem is you might have a situation here where the date is the 27th of March, and the report allows the end user to set a range like 123 days. Well, you've got this period for March, which it's not a complete calendar month. And also this period over here where 123 days stretches back to the 24th of November. So the problem is you've got 7 days where it's not a complete month. So what horizontal ags does, and let me open a PBIX file in the background and close one, not anymore.
Oh, I can tell I can tell you closing that model has allowed your computer so your video keeps adjusting. That one large model was eating a lot of your bandwidth, and I guess your video just got really large because it said, "Oh, I have room. I can give you more video
Oh, I
feed."
can
So
relax.
let me transition here to another screen real quick. Hold on. All right. I think we're still good. Okay, got the audio back on. Okay, go ahead.
Yeah, so this what horizontal ags as a technique looks to solve is how you can take ranges of dates that don't fit nicely into normal buckets like weeks or months, for example, and still allows you to get the benefit of faster ags. So this technique does not use ag awareness, the automatic mapping built into Power BI desktop and Power BI service. This is a manual hand-built DAX technique. So you've got 123 days in a date range. We can't use a complete calendar month based aggregation strategy. And likewise, if we had the same 123 days, and we had a table which was broken down by calendar week, well, from the same date end date going stretching back, what we have is a period where 3 days from the base table do not fit nicely in an aggregation that's based on calendar week. And also there's a day out here at the end. So what horizontal ags does is in DAX, it combines the two. So let's say, we are here and we're looking back to here, for example, and we know that we have got a set of ag tables which are based on calendar month, and we have some based on calendar week. Then the idea is to split the work up, is to detect, okay, how many days overlap do we have if we were to resolve this date range just using months? So we can see that we have 2 days left over here and we have 5 days left over here. And now let's do a calculation where we count the overhang based on the weekly ags. And the weekly ag equivalent is we've got only just 1 day that we can't cover at the beginning, and we have just 2 days to cover at the end. So in DAX, we can test how many overlap days are there likely to be, and how many buckets are we going to resolve. And what we can do is we can do one calculation which uses the ag table that best suits, and then all we do is we go to the detail table and only get the data we need for, say, these 3 days or these 7 days, and stitch them together on the fly. And what does that look like? We have a visual here which is using horizontal ags. So we have a measure here called events using only the base table. So
Oh,
this
I don't think
measure
I don't think we're
is
seeing
nice and simple.
your measure.
Ah,
There we
yes,
go.
yes. Okay.
Now we
No,
go.
you're not.
Now we're
I
seeing
am.
it. So now we're looking at that number and on the ag table there.
Yep. So we have 50 billion. This is that 50 billion row table. So this top measure just performs a sum of the underlying
Do you mind making,
column,
yeah, can I ask one more
and
question?
it
Do you
doesn't
mind making
use.
the DAX formula bar a little bit larger? Or you can just do the scrolly wheel. There we go. Perfect. That's much
Oh,
better.
yeah, absolutely.
You know how to do that? Yeah, perfect.
Okay.
Yep.
Whereas this measure, what it does, events calculated using the, spelled that wrong, horizontal ag measure, looks like this. It's not so bad.
No, it's, just a little bit of
And if
code.
we scroll down, I'm not going to go through this line by line, but it essentially on the fly considers how many gaps would we have if we use the monthly ag cover, how many gaps would we have if we use the weekly ag cover, and then based on that we can go and get the relevant blocks of data from the relevant ag table, and then so on the gaps. And to prove that it works, if I randomly drag this date range slicer what we can see is that these numbers will always match, even though they're arriving at different values. Now, what's not so easy to see here is that the horizontal ag measure is going to be more efficient because it can do it in much less work in terms of scans. And if I do the end, I'm picking just random, start and end dates. So the bottom measure is always exactly the same value, which is really important, but it's going to take advantage of in my table, in my data model. I should have shown this probably at the
Have you
start here.
documented? Is this documented too, Phil? Have you
So
written is it in the blog
yeah,
post?
yeah, I've got a blog on this. I go into this detail. Yeah. So I have an event table here, which is not aggregated. So that has, the equivalent of 50 billion rows. Then I have a version that's aggregated by week. So that's, just hypothetically, this is going to be 1/7 the size of the event table. And a month version, which is going to be 1/30 the size of the event table, assuming everything's distributed normally. And what I can then do is using my measure is determine which of these ag tables should I use, which blocks of these ag tables can I use, and then what's left over. And I can come back here and get much less data than, and this is going to really, really help when I have a big long date range as well. So that's an interesting technique, but it doesn't work if you've got gaps. Now, how did this work for this customer? I've got some numbers here.
Oh, perfect, because that was the
So
next question someone just asked. They said, how long can you show how much faster this
yeah,
was
yeah.
running?
Yeah, so the first three dots to the left here were me running a set of queries over the system with no eggs, with nothing existing. And I ran it 3 times just to get an average, just a nice benchmark to make sure that things were behaving. And as you can see, that nothing really changes between them, so that's kind of good. So the set two, the next 3 columns, with just only with monthly ags. So if you can imagine me writing the code to say, let's take whatever random date range that you supply, and these were built and baked into the query actually. And when you can satisfy, when you can satisfy them from the month, then do that, and then just go get the overhang. Don't look at the week table. Just use the month table and get the overhang from the detail table. And what we can see is some queries sped up significantly. So the y-axis here is how many milliseconds. So we've got 5-second queries, 10-second queries, 15-second queries. Our slowest queries were taking 42 seconds. Some of these 42-second queries sped up to about under 15 seconds. And these will be the ones that were able to fit perfectly in a month range. So just by sheer coincidence, the filters were on a calendar month. So there was no need to go and touch the detail table. Some queries actually got slower. So these might have been maybe where you had a date range that had 25 days before a month. You only have 1 month, and then you had 25 days after a month. So you actually end up spending more time using this technique, simply because the date range don't suit it. But most queries sped up a little bit, some a lot, some did slow down, and it was just by the nature of the date range. So the third set of bullet points were the same test run just using weeks. So we were doing all the same date ranges, all the same queries, just replayed, but with the measure now configured so that it would consider the weekly blocks and then go back and get the overhang from the detail table. Wouldn't consider the monthly table at all. And again, most queries sped up, some slowed down a little bit. And again, that was just the nature of how much overhang you've got versus how many times you're hitting the ag table. But then finally, what we did was we had a run where we combined the two. So each query can consider how many can I get from the month, how many can get from the week, and just get the overhang. And the slowest query was, all the queries were under 10 seconds. And this is a huge data set. And all of them were basically fast. There might be a small number of queries in here that maybe slowed down a little bit overall, but the just massive advantage. For this data set, I'm not saying that you apply this technique for all models. It really does need to suit the query patterns and the workloads and the data layout. And horizontal ags suited this particular challenge quite nicely. So something to consider. So that's horizontal ags. So that's taking we've got two eggs in our model. One's nice calendar months and one's nice calendar calendar weeks, 7-day buckets. So the next technique that I'm going to talk about looks at the same challenge. But what we're going to do is talk about accordion eggs. And one thing I learned from accordion eggs was I couldn't spell accordion. I was always spelling it D-I-A-N, or when I was touch typing, it took me a little while to really always go back and fix my spelling mistakes. The red squiggles come under. So what if you had two ag tables in your models? One based on week, one based on month, and you want to do something similar to what we just did. You want to have date ranges, etc., or potentially not even date ranges. Can I combine those and only have one set of ag tables? So rather than have a whole set of tables that are grouped by month and then a completely set of tables that are grouped by week, that is a lot of extra tables. So what accordion eggs allows you to do is allow you to provides the same level of aggregation, but using only a single set of tables. Now, as you know, calendar weeks don't play nicely with calendar months. They never align nicely. So how does that work? And that's because typically with classic eggs, people find mentally it's easy to think about a nice, consistent set of buckets of days. What accordion does is, let's say we have, a date range like this, and really simplistically, we have some transactions which start on the 1st of March, and then we've got one transaction a day, and on every day, coincidentally, we just have the same value over and over and over again. The way accordion eggs works is, let's imagine if you marked each row of the transaction table with an X when it's a boundary of either a week or either a month. And let's imagine our week starts on a Sunday. So what happens is the 1st of the month, we consider that to be a boundary day because it's the 1st of the month. But then every Sunday, we also mark that with an X. So we go through and mentally decide, okay, here are the X's. And now down here, the 1st of April is an X, okay, because this is the start of the calendar month. Now remember, we have a value of 10. So how can this compress down into an ag? So our first row over here, which is Friday the 1st of March, has a value of 20 because we're aggregating or summarizing two rows. The next block of data is the 3rd of March, and that has 7 rows. So we've got 70 and 70 and 70 and 70 and so on, etc. But then finally down here on the 31st of March, we compress one row into one row. And then on the 6th of March, because it's a Monday, it covers 6 rows, and go on, etc. So what we have here is a table with about 40 or 50 rows, compressed down to 1, 2, 3, 4, 5, 6, 7, 8. So it's a compression did I do the maths mentally? 5x, 6x in terms of compression. And that gives you the shows how you'll get that benefit in speed.
This is so clever. I'm looking at this going, I'm astounded, but this is so cool. The ag, I kept thinking the ag again. This is so much fun for me because I'm looking at it going, wow, this is just blowing my mind because the aggregations don't have to be equal weeks. And where the aggregations, the DAX is smart enough to figure out where things are hitting inside the aggregations and saying, oh, I see that this falls within some sort of ag because the dates align with the X's, and it worked. Oh my gosh, again, my mind is just freaking blown. This is so cool.
Yeah, so I have my fact table, 1 row per event transaction. So this is, is it even imported? Oh, it's imported even too. That's pretty cool. So over here is my accordion ag. Now my start date of my accordion ag is, if I go and have a look at these, my compressed table, my start dates are following that pattern. So they'll be every Sunday, and then they'll be every 1st of the month. And the value that goes into the aggregation column will give you the appropriate sum. So that means if I want to run a report that happens to match perfect calendar week periods, so this is different to horizontal ags. These have to match perfectly. If we hit perfect weeks or we hit perfect months, then what we can see is how many events took place. This is the summarization of 13 of these buckets. Now, even though we are asking for 13 weekly buckets, there are 15 actual buckets in the system because we've got those calendar month starting periods. So what is in reality 13 weeks covers a 90-day period or 91-day period. We can solve in 15 rows, which is only 16% of the number of rows. So you can get a 5x to 6x times improvement here. And like here, if we can have a reporting period that says, just give me then sum of events. And if I have a look at my event measure, what is this doing? And I think this actually does use ag awareness. We're just doing the normal sum. And, for a 3-month period, we're covering 99 days. Actually, I don't know why it's showing me 99 days. It just might actually be falling off the start of the date range. We can resolve this in just 18 buckets of the aggregation table, so 18%. So again, it needs to be fitted to your common reporting patterns, and we had people that like to report in weekly buckets, but needed to be able to report in a variety of weekly buckets, but separately monthly buckets. So we didn't want to maintain a whole set of monthly eggs and a whole set of weekly eggs and have to refresh these sorts of things. And we could do it in one set. And so that's an idea. That's a technique that you might want to consider. And if you really want to go crazy, you could actually probably mix and match accordion eggs with horizontal eggs to handle things like offsets to give you the ability to report on periods that don't fall neatly into weekly and monthly. You could get take the speed of the ag table to get the bulk of your data, and then just finish off the remaining data from your event table if you want.
So
So
Dan,
that's kind of cool.
Yeah, so Dan asked
Keeping
us,
my eye.
I think, a question right along the line of this. So his question is this using the aggregation awareness directly in Power BI with the Accordion aggregation? So everything we're doing here is all so clicking manage aggregations like you're doing here, this is the aggregation awareness, right? That's when we're starting to turn that on. Is that what that means?
I just have to refresh my memory. Let's have a look. It is. Okay, so this is using aggregation awareness to resolve this. So there's no DEX involved
So
in
this
this.
means, so every time we see this window,
Which,
so when I see, again, I'm making sure, I have not seen this, I haven't really heard the aggregation awareness piece. Every time we're in the manage aggregations window, that is when we're talking about the aggregation awareness pieces. Okay,
yeah, so that's the
perfect.
automatic mechanism to determine for you. Now, what that means is you don't write complex DEX. You just write a simple, I'm going to sum a value here or sum a value here or count whichever, and the engine will automatically use this table if it can. If it can't, then it will drop back, but you don't have to configure it with code, etc. The previous horizontal eggs, you have to write DEX code to decide when to use the egg and when not to use the egg. But accordion eggs is nice and simple in that regard. So this column here is using a event. Yeah, so it thinks it's using the underlying very large table, but in reality, it's been directed to the summary table. I mean, I can show you how you can test for that.
I'm going to go to a view
Let's
here of all three of us on
like,
the side here so that everyone can see. I can see right here from the video, Seth's mind is just like oozing out his ear. I can just see it just kind of trickling out the corner here on his head. So I just thought I would let everyone enjoy what I'm seeing on my side, on the the producer side. I'm stinking floored. This is so cool. But I mean, to your point there, Phil, just, I mean, as the thing is automatically doing these aggregations for us, that means the engine's actually writing the DAX to intelligently grab the thing. So it's doing DAX still, but it's just doing it internal to the program. We're not having to write the complex DAX to do that. Is that kind of what's happening there, really?
correct. Yeah, so what I've done is I'm capturing the DAX that lives behind this
Okay.
visual here, and I'm going to throw it over into DAX Studio
Sure.
connected to the model. So we're running a simple
Can you
calculate
make that a little bit larger
sum.
by chance? Perfect.
Take this out. because we want to sum this table. If we turn on server timings and run this, we're
Let's do it.
freestyling a little bit here.
What the heck?
So it hasn't kicked in. It has kicked in. We're doing some subtotaling here. Let's go really clean this out. So evaluate sum of and type this in. How are we
You
going for
just keep
time?
going. I'm just enjoying myself. Let's go through all of them. I don't really care. Like I'm learning so much right now and having such a blast with this. This is super cool. This is why I wanted to get you here, Phil, because this is just really neat stuff. Don't worry about time. Just keep going.
Okay, it doesn't look like egg awareness is kicking in this model. Am I connected to the right model? I thought I was.
You should use your external tools there. Also,
Yeah.
you can download them from
So
Business Ops, except for DAX Studio. DAX Studio has its own thing.
absolutely.
Speaking of which, Phil's got his own external tool that does some beautifying of DAX things. So I have a task item for myself is to learn how Phil's tool works, and that is going to be added to Business Ops as well. So we'll get a Phil Seamark section just for you guys in Business Ops. So that's coming. It's on the way.
Yeah, although my ones aren't necessarily designed as end user go for it. So it should be all kicked in, but
Okay.
doesn't seem to be. Oh, I know why. It's ag awareness will only work if your fact table is in DirectQuery mode. And in this should be DirectQuery mode. Okay. Should be kicking in, but I'm not seeing it. But anyway, it's the theory and the technique of how you can construct your ag tables using different techniques to to solve these challenges. I might come back to that at the end and have a bit of a play and show that working. But what I was hoping to show you was in DAX Studio. There's an event that kicks in that will tell you that that the aggregation awareness has found a match and it's using this table instead of this table, even though my calculation is running over this table. I mean, it is work. Actually, no, it is working because we can see here that even though I'm trying to query the fact.myEvent table, which is in DirectQuery mode, there's a couple of things here. The subclass is scan. Normally that's SQL. If that's SQL, but it's showing a scan, so that must be on the import table. And the import table is showing fact.myEvents. So it has remapped. But sometimes you can see here in the DAX Studio window that it's there should be like a match found. We should
file a bug with the
or
creator.
A match failed,
I'll get him
depending.
here next month. We'll get him here and we'll show him this. We'll start filing a bug with Darren.
I'll be talking
oh, okay,
to
good.
them
He's a
later
good guy. I
on
love him to
today,
death.
and
He's so good at what he does too.
Yeah. So believe it or not, this is working. I'm querying this table, but the engine is actually directing it to here, and it's taking just no time at all to run, and it's a very large table.
Awesome. Love this.
And it's a small model. So let's have a look at the next technique. Filter DAX. So you were asking earlier about picking and choosing what you put into the aggregate table. And in fact, what this does is consider the idea of hot and cold data. So you have a very large fact table that stretches back in time. So let's say this goes back 2 years. And you know that the vast majority of your end users only like to query stuff that's happened recently, say 3 months or 6 months or whatever. You can just determine what that dynamic time barrier is. And then the idea is you design your model so you have aggregate tables. So your hot data is always in memory. Everything above the dash blue lines is import in memory. Everything below the dash lines is DirectQuery. And just imagine it's really slow. So you don't want to be hitting this red table. So with this approach, if I said, show me some of whatever of this, sum up everything in this column for something in the last 10 days, Ag Awareness can kick in and it can go, I can get that from one of these two tables. I've got a high grain egg that's at, by day. I've got a super high grain egg that's, by month, and it can hit from this one, and it can satisfy it, and it returns very, very quickly. And what this allows you to do is make better use of your capacity, because you don't want to load all of your data in. In fact, you don't even want to necessarily load aggregation versions of this, all of these in. So really what this is trying to do is provide you with a mechanism to determine a point where everything after the line, or more recent from a line, is hot data and always in memory, and everything after. Now, the trick about this is what you can do with an ag table like this, and this is the key. This is this ag table one here. It's not aggregated at all. It is if this block here after the dynamic time barrier has 10 million rows and 20 columns, then this ag table has 10 million rows and 20 columns. It's exactly the same. It's a one-to-one match on rows here, because you can use the ag awareness feature to do that mapping for you. So that means even if I'm trying to query at a detail level, the grain of the fact table, it'll match to here. It'll actually use the in-memory version of the table rather than spill out to DirectQuery. And that's, still gives you the ability to say, rather than load the entire fact table into memory and make my model really big, I'm only going to load a portion of my large fact table into memory. But what you have to do in with Power BI is still create the ag table, but it's an ag table that can never be missed. So if I try and query any of this in here, it automatically always uses this here. But then what you can do is this period here, we have the entire rest of the 2-year period will get satisfied queries at a super high grain and at a high grain. But then if you do happen to run a query that says, this is 6 months ago, I want 8 months of data, then it's going to use some of this and it's going to use some of this. Now I have got a version of this using worldwide importers, which I'm going to open over in my other window. I'm going to close down some earlier PBIX files that I have open. And we call it filtered ag because we're sort of filtering, deciding what you can keep in your aggregation table. Now, time is an obvious thing, but you could create ag tables which perhaps only contain certain countries. Rather than every country in the world or every city, you only create ags over the 10 most popular items that you do. You bring that into memory, and if your end users are hitting that, those countries or geographies or whichever, it's satisfying the queries from the in-memory table. But if your query hits other countries or other regions or anything that's not included in this ag table, it just drops out to the detail table out here. And filtered ags is still
I'm
loading
thinking
up.
through this with you, Phil, and I'm thinking here again. I'm trying to think through optimizing this again from maybe a cost structure as well. I'm looking at this going, okay, this is really cool because I can then say I have a little bit of hot data and I have some cold data that will then query the latter part of that those ags in the history there. I'm also thinking, does this work in? So again, I'm assuming here that we're talking very large data, but does this work on like SQL on demand and Synapse with Spark? I mean, what I think, I mean, the core of what we're talking about here, a lot of this, the aggregation things here, are really centered around we need a kind of like a SQL-esque like engine that allows us to direct query some of the raw data in its original source, right? So like a Synapse is a great solution here because then I can do SQL on demand. I don't need to have the SQL running all the time. So only that turns on when I need it. Will these aggregation tables work with the SQL on demand as well?
Oh, probably.
Probably. I like your answer. Because what I'm thinking though is if I build my reports so that everything lives in the last 90 days, and I have potential reports that need to go on for like a full year of data, I could, pre-filter all my reports to be 90 days, and then on the occasion that when someone needs to go longer for the data, this makes a lot of sense to me because if I'm grabbing a full year's worth of data and trying to suck it up into my report, I really don't. I want the performance to kind of be a little bit slow because I'm kind of trying to manipulate the user behavior so they stay in the current 90-day time range, and then when they leave that range, it just gets sluggish. And we was like, well, that's why we make the 90 days fast. I want you to stay there. That's the important information that you need. You don't need to go back, a year and a half from wherever that is.
Yeah. Okay. So in my diagram here, what I have done is my actual physical data source has one table, one fact.sales table. That's it. But what I can do is I can say I can create two versions of that table in my model. These are both still DirectQuery. So I've got DirectQuery hot and DirectQuery cold. So it's really just me drawing that line to decide everything in the hot table is, say, everything after the 1st of September. And in this table, it's everything prior to this 1st of September, but it really is the same physical table that, so it's kind of like using tables as partitions. So we've got two partitions, one that's in old and one's hot. However, these both sit in DirectQuery mode. But over the hot table, what I can do is I can have, say, a number of aggregation tables that are import in memory. Now, each aggregation table increases the size of your model. But on the cold table, sitting above that, I only have, say, one aggregation table. That's all. It's by date here. So, the smaller the grain. So in fact, actually, this should be a higher grain. So this should be higher up, and this should be lower down. Okay. So what that means, if I want to know what is the sum of quantity for all time and by day, and what that means is I can get the everything before the time barrier from this aggregate table and from this aggregate table, and I can add them together, and that'll be very, very quickly. So my result will use this table plus this table, and everything comes from in memory, and it will very quickly. But if I then decide to slice and dice by city, and I'm still looking at all time by day, then what will happen is I can use this aggregate table to use to satisfy all my queries up, back to my time barrier. But then what I need to do is it'll drop out to here, and it will use a slower direct query table to go and get that number, add them together, and it'll get the result. But if I want to slice and dice by city, and I'm only looking at recent stuff that only ever falls in the what's considered the hot range, then I can use either one of these two queries, and it'll be very, very fast. So you need to make sure that all of the boundaries of these are in alignment of all of these tables. So you can use that get date minus whatever, and you refresh them. I don't know if I've got that easily visible in here. Power Query Editor, it might be the SQL statement. Let's have a quick nosy to see if the pattern jumps out at us. So the advanced editor.
Another question came up, Phil. I think this is a really good one. Fernando asks, when you're on the visualization, so we're talking modeling side here. When you're back to the visualization side, Power BI you're just picking one data field and putting it on a visual for the report
Correct.
visual, and Power BI is making all the decisions for you about, do I use an ag, do I not, what does that look like? It happens seamlessly to the end user or the report builder at that point.
Yeah. So each of these hot and cold tables, whether you're the fact table, your imported, your aggregation, they all use the same where clause. You're the greater than the boundary, or you're less than or equal to the boundary. So it's important that you keep that in sync. So how does this look? Let's do some metrics over the quantity column here, and let's see what the measure looks like. So we've got sum of quantity, and we've also got what the dynamic time barrier happens to be, which I think is 3 months period prior to this. My screen is just still catching up. Wonderful. So the sum of quantity measure just says, based on my date range, the values that are in filter context for dates, do I have, well, first of all, always sum up, what's hot in quantity. And, because in memories, it's going to be quick. Then add on to that the sum of cold quantity. And remember, these are the DQ tables out in the data warehouse that are covered by aggregations, covered by aggregation awareness. So if we
Oh,
can,
this is slick.
if we're
Yeah.
only slicing and dicing by date, then it will use both aggregate tables for hot and cold data. Now, the barrier must be in here somewhere, but would only bother going to the cold table if the minimum date is happens to be earlier than the dynamic time barrier, and this is all nicely in sync. So it means that if we do this, then we're probably only going to be hitting the hot tables. Well, somewhere here there must be some data. There we go. This is probably only hitting the data. In fact, let's go find out what the time barrier happens to be. It happens to be the 29th of February. So we are before that. So we're actually hitting the hot and cold, but we're slicing, dicing by date, so that's fine. But if we bring in the additional dimension, then like on city, for example, then part of this query will be using DirectQuery, the other part will be using non-direct query. So let's again have a look at that in DAX Studio. If this comes up. Did I hit the right button? Yes, I did. I did hit the button. And my splash screen is opening on a different screen, and I'm about to bring that up. Cool. So let's run a query for all time. Turn on server timings so that we can understand what's going on. So this is not bound by date. It's just going to give us what is the sum. Remember when we had a look at the this measure, it was adding them together. So we do this, and in the server timings, we're probably performing 2 scans. We're doing a scan of Ag Table 1 hot, and we're doing a scan of Ag Table 3 cold. But these are both Ag tables, so they're both in memory, so that's fine. But let's say we want to now introduce a geography which is not covered by these, we're at a lower grain here, and we run that. And we should have one scan and one SQL. And it's taking longer because it's going out to my very slow DW. Or actually, maybe it's going to another data source which is not turned on. This might break because of this data source was probably
Gotcha.
something I set up a year ago, and it's might not looking at. But just imagine this completes, and it might surprise me. I don't know what the data source is. We will have a scan from the switch to here. Part of this query will be resolved. Do I have my SQL database started? I'm trying to switch to my view. Yeah, part of it will come from here, the ag table that we can slice and dice by city and sum up the quantity. But the other one will go to the SQL, which is out here. And it may or may not have come back. Oh, it has come back.
Yay.
There we go.
You
So
didn't
it took
break
5.5 seconds to do the cold. So ideally, this is not suited if you have lots and lots of queries that go to the cold. If you've got a handful and you let people know that if you do want to query old data, it's going to take a little bit of time. But I can make better use of my premium capacity by having, picking, choosing what goes in. And in fact, you can mix and match too. Like you can say if period comparison is quite a popular technique, and if I don't want to pivot, rows onto columns, I can actually mix and match these tables, so I can have hot, cold, and the hot stuff out here is exactly a year prior to here. So you can say do year comparisons and month comparisons, because quite often it's amazing when you boil down the queries that hit a BI system over a period like 3 weeks, how many patterns emerge in there. And this is sort of something we're studying quite a lot lately with the some features coming up with Power BI about how can we automatically generate these for you to optimize the query patterns that your users are firing against your model. So hopefully that was useful.
Well, so
Lastly,
before, yeah, we do have a little
if
bit
we've
of
got
time.
time,
So we're running, we're about 20 minutes or so over the hour. So let's just give it like another, if you have a couple more
yeah.
things, Phil, let's maybe do like another 5 minutes or maybe touch
Oh,
base on the other. I think you have two more ags on your
this is
blog
super quick.
that you talk about. So maybe we can touch on those just really quick and then we can kind of give it a wrap and we'll do the happy hour
Well,
next. Okay.
yeah, we'll just do one.
Yep.
Yeah, we'll just do one,
Perfect.
which is incremental acts. So let's say your fact table and even your ag table is very, very large. It's a huge amount of data goes into it. And you only make a small number of changes. And you don't want to reprocess the entire ag because it can take a long time. Ideally, what you try and do is put in the deltas. So just imagine this base table, but extrapolate it out to be very, very large. So we have 2 days of data. And we have a pattern here with product AAA, BBB, AAA, BBB. Whoop. This is just designed to mentally make sense. We've got store is 10, so that's what store we belong to. And I've got this pattern where the quantity goes 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And that can be summarized down to 4 rows. Okay, and we process this in, and it takes a long time to process in because it's very large table. But let's say to our underlying transactions, we perform a delete, and we perform an update, and we perform an insert. How can we do that quickly so that we don't have to reprocess the entire ag table? And the idea is incremental. So based on deletes, inserts, and updates, we handle them like this. So if we were to delete the second row, if we were to update the third row, remember that pattern was 1, 2, 3, 4, 5, 6. So we updated a 4 to a 10. And at the end here, we perform an insert. So we've got the delete, the update, and the insert. The original ag table, we leave alone. We leave into memory. We don't reprocess that at all. What we can do is a technique in analysis services called a process add. We add 3 rows to that. So the delete, because we're deleting A, 1st of Jan 10, we put in a row that says 1st of Jan A 10, but we put -2. So if we were to do a sum over A for the 1st of Jan, 6 plus 6 plus -2 will give us 10. And that should be exactly the same result as if we were to scan here. Same with the update. Over here, we've updated a 4 to a 6. So here we enter a row for B that adds 6. So if we were to do any calculations on B, summing this quantity, we will arrive at the correct figure. Now, what this doesn't allow you to do is count rows, but you can perform count rows with a column and go -1, -1, -1. So you could sum up that column to arrive at the correct count rows. So through the day, you could basically incrementally add these rows bit by bit. And there'll be a point where if you leave it running too long, the number of rows on the ag table will get close to matching, if not improving or larger than the
Yeah.
side of your fact table. In which case, you just do a process full. So overnight, you do a process full, and your ag table shrinks back to the bare minimum. Then through the day, you keep track of these changes through triggers or whatever mechanism in your source system deltas, and you load those rows into your ag table as deltas, and it's surprisingly good. Of what it can achieve. So yeah, the benefit is your refresh time. You do need to resync periodically, and it just it suits where your ag table is very large, but your changes are tiny, and those changes can be loaded incrementally. So that's another technique that I just wanted to highlight. So just remember, in summary, aggregations can be explicit or automatic. Explicit's where you hand code the rules in DAX, or automatic if you use the ag awareness technique. Both are very good. Both have pros and cons. All of these techniques which I described are over on my blog site, DAX.tips, with a lot more detail, with things that you can download and explore. And if you're interested in applying some of these on your models, my contact details are here. Reach out to me on DAX.tips or on Twitter or LinkedIn. I'm always interested to hear if you're applying some of these more advanced aggregation techniques.
Cool.
If there's questions you want to fire to me, you're very welcome.
I expect I expect you to incrementally aggregate your answers and do them in batches, please. Very bad ag joke. No, it's fine. I think everyone was enjoying it. All the comment threads were very excited about it. People were definitely very much enjoying you running around 50 billion rows in a demo, just willy-nilly. Oh, that was a year ago. Just fire up the 50 billion record analysis services model and just kind of go at it. So that was awesome. So with that, Phil, thank you very much for the great presentation. I threw a bunch of links in the YouTube chat. So there's links for the ags that we talked about. There's actually some addition. There's like one more ag I don't think you touched on, Phil. I think it was shadow models. And so because they're dark, they're like a ninja. Hmm.
Hack with shadow tables is to use a one-to-one ag to kind of create an imported version of the dimension table and import to give you simulate dual, because dual is effectively a DirectQuery table in an
These
import
are these
table.
are these are such ghost things that we lost your audio and Mike took it out of YouTube.
But anyway, hopefully shortly you can do ag awareness over dual, which negates the need to do the shadow model technique. I gather it's going to be out in um,
Don't say
yeah, well,
anything.
I
You don't
think
have
it's
to
out.
say anything. It's going to be out
No, no,
soon.
I think I was talking to some people earlier today on this very thing, and they said, "Hey, why don't you just try it out on Power BI Desktop December, which must be out pretty soon, so it might work." But it's a if you do read my blog on Shadow, it probably is now going to be redundant,
Okay.
which is
So
a good thing because it's a hack. It was more just a hey,
gotcha.
if you encounter this and
Yep.
you apply Ag Awareness, your dimension table performance are going to be slow because they have to be in DirectQuery. But now you can just mark those dimension tables as dual. So when you're populating your slices, it comes from the imported version. But when you're running queries, over your fact table grouping by columns in your dimension table,
Hmm.
you want to push all that out to DirectQuery. It'll fold, and your DQ will do the work, and it'll come back with a nice small tiny row data set, which for your visual can use to draw. Everyone's happy rather than trying to suck an entire fact table, 50
Yeah,
billion rows into
exactly.
Power BI.
Exactly right. Well, well,
Very
Phil,
folding.
well, Phil, thank you very much for your knowledge. It's been absolutely phenomenal. We're going to now transition over to the happy hour. So we're going to see if
Mhm.
Phil can hang around with us for about another 30 minutes. We can ask
Absolutely.
more detailed questions. I'm going to drop in. I'm not going to do this wrong. I'm going to keep the live stream up and I'm going to keep the chat window going. So I'm going to put the link in the window now, and then I'm going to cut the feed here with us. And then I'm just going to hang on YouTube for just a little bit more while people join the Teams meeting, and I'll let Seth kind of pick it up from there. So, Phil, thank you very much. This was a
No
great
worries.
meeting.
Thanks everyone
I
for
learned a
jumping
ton.
in.
Really appreciate it. We're gonna have to get some more fun, very technical topics out of you, and hit you up for some time in the new year. And maybe if things start relaxing a little bit, we can get you over here at some point in the state side, and we'll get you actually at the event or at the group. That would be a lot of fun.
Oh, I'm
And
hanging out
a
for it.
Packer game.
Absolutely.
The event and a
Yes.
Packer
Go
game. That's
Green
what we got
Bay.
to
Yeah,
do.
man, you come this way, and
We will
I
get you
will
there.
make Packer tickets somehow
We will
happen.
figure out how to get you some of those. All right, so the link's going in the stream right now. Thank you those for attending. Here goes the link, and we'll see you next month, next year, I guess. Thank you very much.